Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be solving systems of equations by graphing. Now, in our first example, it says consider the graph of y equals negative 1/2 x plus 7 and y equals 5 over 2x minus 5 that are shown graph below. Problem A, at what point do the two lines intersect? So if we look at the graph of the equation, we can see that they intersect at this point right here. So we just need to name this ordered pair as 4, 5. This is said to be the solution to this system of equations. Now, what we're going to do now is use substitution to prove that the intersection point is a solution to both equations. So I'm going to write down my first equation, y equals negative 1/2 x plus 7. And I'll kind of draw a little t-chart here, and I'll write down my second equation, 5 over 2x minus 5. And what I'm wanting to do is prove that the point 4, 5 is a solution. So in the ordered pair 4, 5, we know that 4 is the x value and 5 is the y value. So I'm going to plug these 2 points into my first equation. So instead of writing y equals, I'm going to write 5 equals negative 1/2 x, and instead of x, I'm going to put in a 4 and then plus 7. And then we're going to evaluate that. So 5. So negative 1/2 times 4 is negative 2. So 5 equals negative 2 plus 7 is indeed 5. So 4, 5 is a solution to my first line. Now let's see if it's a solution to the second line. Okay, remember I'm going to plug a 5 for the y, and I'm going to plug in a 4 for the x. Now let's evaluate that. This would be 5. 5 over 2 times 4 would be 10. And 10 minus 5 would indeed be 5. So the point 4, 5 is a solution to both equations. All right, now let's define a system of equations. A system of equations is a set of more than 2 equations with the same variables. The point of intersection of 2 graphed equations is called the solution of the system of equations. The solution to a system of equations is the ordered pair that makes both equations true, as we found in our first example. All right, let's look at another example. Frank and Erica are selling ribbons to raise money for the football team. The graph shows the linear relationship between the number of ribbons each of them has left to sell and the number of days they've been selling ribbons. Indicate whether each statement is true or false. If the statement is false, rewrite it so that it is correct. All right, our first statement says the solution to this system is the ordered pair 15, 18. So let's go to 15, 18 and see if that's true. So I'm going over 15, which would be right in here, and up 18, which would be right there. All right. Now that did not land on both lines, so this would be false. The real solution to this system would be the point right here. And so that point would be 18, 15. So they just had it backwards, which is a very common error I frequently see students make. Okay. All right, the next statement. On day 24, that would be right. So let me get a highlighter here. On day 24, that'd be right here, the number of ribbons sold by Frank was less than the number of ribbons sold by Erica. So let's see, Frank and Erica. So on day 24, we want to figure out how many ribbons were sold by each of them. So on day 24, we have a point here. This is on Frank's, on Frank's line, and that would be 9 ribbons. And on day 24, it looks like Erica sold 12. Now let's go back and read the question. On day 24, the number of ribbons sold by Frank, which is 9, is less than the number of ribbons sold by Erica, which is 12. Well, that is true. No need to rewrite it. All right. On day 18, let me erase all this. On day 18, the number of ribbons sold by Frank was equal to the number of ribbons sold by Erica. So let's see, Frank, Erica, and this time we're looking at day 18. All right, so on my graph, I want to find day 18. That's right here. And we have an ordered pair right here. And sure enough, they both sold 15 ribbons on that day. So this statement is also true. Now, one of the main things we're going to be doing today is learning to solve a system of equations graphically. In other words, we're trying to find the point that makes both equations true. So in example 3, it says solve the system below graphically. So we have y equals -4 thirds x minus 5, and we have y equals x plus 2. So what we want to do is graph these individually and see if we can find their intersection point. So for our first equation, we have a slope of -4 over 3, and we have a y-intercept of 0, -5. Now, when you are trying to solve a system by graphing, and you graph your line, you want to put as many points as possible on that line on the graph to make your sketch as accurate as possible. So I'll start at my y-intercept, 0, -5. 1, 2, 3, 4, -5. Okay, so there is my starting point, 0, -5. Then my slope is -4 thirds. So my top number is negative, so I want to move down 4. My bottom number is positive, so right 3. Unfortunately, on this graph, I'm not going to be able to move down 2, 3, 4, and right 1, 2, 3, because it's going to be like off the grid somewhere for this next point. So what I'm going to do is show you that if you go off the grid, you can go the opposite way. Let me put that 1, 2, 3, 4. I want to put that point back on there, 0, -5. So if I can't go down and right, I can go, let me put this in a different color so you can see it better. Let's see. I want to go, if I can't go down and right, I can go the opposite direction, which would be up and left, and you would still be on the same line. Up and left, okay? So, go 1, 2, 3, 4. We went up 4. And we're going to go to the left 3. So 1, 2, 3. And that's where your new dot will be. Now we'll do that again. Up 4. 1, 2, 3, 4. And left 3. 1, 2, 3. So I've got a new dot there. So I put, remember I said you want to put as many dots as possible. Okay. So that line's going to be like that. All right, for y equals x plus 2. Now I might see, can I erase some of this so that my next line is a little clearer? Let's try to erase that. Okay, let me just draw this line so it's a little bit straighter for you. Okay, all right, so for my next line, my slope is positive 1. I need to write it as a fraction. My y-intercept is 0, positive 2. So I'm starting at positive 2, and I'm going up 1 to the right 1. So let me write that. Up 1 to the right 1, up 1. Now, do you see if I keep going up 1, right 1, I'll never, ever intersect the other line? But I can go the opposite way. I can go down 1, left 1. So let's do that. Down 1, left 1. Do you see those are on the same exact line? Down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. And now, once we do that, we can clearly see where these two lines intersect. Let me highlight it for you right here. And so all we need to do is name that ordered pair as a solution. So 1, 2, 3, negative 3, and then down 1, so negative 1. So there's our ordered pair. All right, example 4. Solve the system below graphically. So our first line is y equals 5, which there's no x, so I could rewrite this as 0x plus 5. Okay, that means my slope is 0, and my y-intercept is the point 0, comma 5. So 1, 2, 3, 4, 5. So 0, comma 5 would be right here on the y-axis. I have a slope of 0, so I'm not moving up or down. I'm just going to the right 5 units. 1, 2, 3, 4, 5. And remember, we want to fill up the whole grid, so go to the left 5. 1, 2, 3, 4, 5. So we have a horizontal line at y equals 5. That's our first equation. All right, our second equation is y equals negative 1/2 x plus 3. So our slope is negative 1/2. Our y-intercept, 0, comma 3. So 1, 2, 3. So there's our beginning dot. And our slope is negative 1 over 2. So that means down 1 to the right 2. So down 1, right 2. Down 1, right 2. Down 1, right 2. That's as far as I can go in that direction. So now I'm going to go the opposite way, which would be up and left. Go the opposite way, up and left. So up 1, left 2. Up 1, left 2. And now we can see where the two lines clearly intersect right here at this ordered pair. So we just need to name that ordered pair. So 1, 2, 3, negative 4. 1, 2, 3, 4. So it intersects at the point negative 4, positive 5. There is our system. All right, pause the video and try example 5 on your own. All right, welcome back. Let's see how you did. All right, I started off with the first equation, and I said the slope of that first equation was 2 over 3. The y-intercept was 0, 2. So I started at 2, and then for my slope, I went up 2 and right 3. So up 2, 1, 2, 3. Up 2, 1, 2, 3. That's as far as I could go in that direction. So then I went the opposite way, which would have been down and left. Down and left. So down 2, left 3. Down 2, left 3. All right, now I filled up the entire grid with that line. Let me draw that straight. So there's our first line. All right, let me change colors. For the second line, our equation was 2/3 x minus 4. So again, my slope was 2/3. I don't know why I put the x. And my y-intercept was 0, -4. So 1, 2, 3, 4. So there's my y-intercept at -4. And I'm going to go up to right 3. So 1, 2, 1, 2, 3. Up to 1, 2, 3. That's as far as I can go in that direction. Now down to left 3. That's as far as I can go in that direction. Now, hopefully what you noticed about these two lines is that they are parallel. And parallel lines never intersect. So this problem, there is no solution. And we have a symbol we use for no solution, and it's a 0 with a slash through it. So it is possible to have a system of equations that has no solution. If you do have no solution, that simply means your two lines were parallel. And this concludes today's lesson, Solving System of Equations by Graphics.